welcome to this module 2 and topic 4. So here we will give you kind of a basic understanding of all the supervised machine learning algorithms. So first we will start with linear regression, then we will explain your k-means algorithm, then in between of them we will give you a little bit overview about logistic regression. So after that we will try to implement all these algorithms with the help of in case of your Excel software, and so one extra topic we will be covering, that is the decision tree, that will be covered after these 3 topics. Initial 3 algorithms are explained. So we start with linear regression. So what is linear regression? Linear regression approach is nothing but a statistical approach which nothing but try to establish relationship between your independent variable and dependent variable. So definitely dependent variable is with that particular variable you want to predict, and the independent variables, you are basically the predictors or the features which are used to predict that particular dependent variable. Now if we just represent this entire regression equation with this with the help of simple expression, so basically that can be written as, so y hat equal to intercept I, or okay, so plus beta 1 x1 plus beta 2 x2. So this is the expression. Now here this y hat is nothing but the predicted value, or you can consider this is the predicted variable, or your dependent variable. I is the intercept, and this B1 is the regression coefficient, and X is your variable, or let us say your feature. So independent variable. So what is the significance of this beta 1 and beta 2, basically the regression coefficient in a regression equation? So these are nothing but giving you the importance of that particular independent variable in case of the prediction of this y hat, or let us say your dependent variable. So let us say if I have in a model, if I get this kind of a model in the sense that okay, y equal to I is again the intercept is nothing but, let us say I am just considering a value 0.4, then your beta value is somehow, let us say 0.2 x1, and your beta 2 is, let us say 0.02 x1 or x2. So then I can easily consider that okay, x1 is more important or more contributing in the prediction of y in comparison to x2. So so you can consider this is nothing but the weightage of or importance of x1, and this can be a importance of x2. Now what is this intercept? So if I consider that okay, x1 and x2 0, basically the value is nothing, then there will be remaining part of that 0.4 or the residual part of 0.4. So this is the basic or average minimum value that is available in case of prediction. And if you just check this y hat, this is not the original value, this is the predicted value, okay, for any particular variable. On the other hand, if I just go to the basic principle of any regression equation or regression modeling, the underline is that all these variables y, x1 and x2, they should follow a normal distribution function, or these data, whatever the observation you are using for calculating these values, they should follow a linear regression, they should follow, sorry, a normal distribution. So hence the prediction error, let us say if you have an original value of y, and the error E is equal to y minus y cap, this value should also follow the same normal distribution. Now, what is the basic logic of calculating or training the model? So, when we are training that particular model, we are actually trying to minimize this, or we are trying to this E square basically. So, if I just write this, while training, so I am using another color. Of the model, so we are using E square, that is y, that is original observation, minus y cap square. So, if I put I and then if I put sum, so this is the term that we are trying to minimize. In case of the training process. So, that is why this approach is known as least square approach or least square error approach. So, basically I am trying to find out the minimum error, so or error square, which will lead to identifying that specific value of these two values or the regression coefficients. So, if I just simply represent this problem, so now this is beyond the scope of the course, till I am just writing that problem, optimization problem. So, those people who are little bit interested in mathematics or optimization, they will be understanding this. When your yi, so I am just putting is original or your observation yi minus your y prediction I square, or yi minus, if we just put this value, let us say I minus beta 1 xi, then minus beta 2 xi1 xi2, and you are subject to this beta 1 is from minus infinite to plus infinite, and again beta 2, this also lies between minus infinite to plus infinite. So, this entire problem is solved through your training process, and you actually get this value beta 1, beta 2 and I also. Okay. So, this I also you are getting the same. So, hope you understood the basics of this linear regression and how to use this. Now, after this we need that how we can calculate the actually efficiency, or you can say the accuracy of the model. In that case, we generally use this formula of R square. This R square is nothing but, again I am just removing this. So, S is nothing but the ratio of SSR and your SST. So, that can be easily calculated with the help of some y estimation by y bar, or and okay, divided by yi, or your original observation, divided by y bar. So, now this y bar is nothing but it is indicating the mean observation. Okay. So, this ratio generally lies between 0 to 1. So, definitely this entire term, this R square, indicates how much this independent variables are explaining the variability in the predicted y, and the higher value is desired. Let us say definitely if you have two models, the first model may be first model giving of 0.5, Another model of given second model may be giving you R square value is 0.7, 0.7, then definitely this 0.7 is better model than 0.5. So this is how you generally try to evaluate your regression models based on the R square. Another thing is that another metric we generally use, that is RMSE value, or sometimes it's used as MSE. So basically if you just take the square of RMSE, you will get the MSE. So that is nothing but square root sum y hat minus y square divided by n. So this n is number of observation, y hat is nothing but the your predicted value, y is the original value or observed value. So you just taking the difference between your observed value and predicted value and taking square and summing it and divided by number of observation. So if I just calculate MSE, mean square error, so that is nothing but the sum of y hat minus y take square divided by n. So generally these are the couple of matrices which are used to evaluate your regression equation. So next we will be understanding the concept of logistic regression. Thank you.